The content and examples in this course show base SAS 9.2. To learn about important updates for SAS 9.3, you can click the SAS 9.3 links that appear throughout the course. In this lesson, you get an overview of SAS software and how you can use SAS to access, manage, analyze, and present your data. You learn about the different ways of running SAS, and you also learn about the process of planning, writing, testing, and revising SAS programs that you use as a SAS programmer. Finally, you learn the basic structure of SAS programs and what each part of a SAS program typically does. In short, you'll learn some important SAS concepts that lay the foundation for you as a SAS programmer. Here's what you learn in this lesson. SAS is a highly flexible and integrated software environment that you can use to access, manage, analyze, and present your data. The foundation of SAS software is called base SAS, which provides the basic functionality in SAS. You'll focus on base SAS in this course. Click Details to learn specific ways that base SAS helps you as a programmer. Then, return here and click Continue. To extend the capabilities of base SAS, you can add other SAS components. For example, you can use a component to access your data. Other components give you tools for report writing, high-resolution graphics, statistical analysis, visualization and discovery, and business solutions. In this course, you'll use 3 additional SAS components. 2 are for data access, and 1 is for graphics. Let's look at all these SAS capabilities in a simple framework. No matter what type of business or industry you work in, you need to access your data. You might have data stored in SAS, in a raw data file, in Oracle, in Excel, or in other types of files. Using SAS, you can read any kind of data. Once you access your data, you might need to manage it. For example, you might need to subset data, create variables, validate and clean data, or combine data to get it ready for analysis. SAS gives you excellent data management capabilities. You'll probably want to analyze your data as well. You could perform some simple analyses, such as finding frequency counts or calculating averages. Or you could run more complex analyses, such as regression or forecasting. For statistical analysis, SAS is the gold standard. Finally, you need to present your data meaningfully. You can create list reports, summary reports, or graphical reports. And you can print these reports, write them to new data files, or publish them on the web. To give you a clearer picture of what you can accomplish using SAS, let's look at a few reports. We've created some reports to give you a sense of SAS capabilities. The reports are based on Orion Star data for warehouse employees. You'll see some simple reports, an example or two of managing data, a few common types of analyses, and some graphical reports. Here we go. Our first report is in HTML format. This type of report simply lists your data. You see columns for employee ID, job title, salary, gender, date of birth, and manager ID. Take a look at job title. The values here are codes that you can't interpret unless you know the data. To make these values more meaningful, you can format them as shown in the second report. For example, you can display 1 as Warehouse Assistant 1, or M as Warehouse Manager. You can also display female and male instead of F and M. Here's a question. What is this report grouped by? The report is grouped by gender.
Here's a text version of the same report. In SAS, this type of output is called listing output. The third report is a distribution by job title. Here's another question. In this report, which job title represents the highest percentage of the total? 10 individuals have the job title Warehouse Assistant 1, making up 55.56% of our data. The fourth report, also in HTML format, gives us some simple summary statistics. Take a look at the mean or average salary for each job title. Now try this question. Which job title has the highest standard deviation? The Warehouse Assistant 2 job title has the highest standard deviation for salary. Warehouse Assistant 4 and Warehouse Manager each have only one person, so they have no standard deviation. Here's the listing version of the same report. You might also want to produce more advanced statistics in your reports. The fifth report shows the mean, the median, the mode, and other statistical measures for salary. Let's scroll forward in the report. One interesting part is the extreme observations. These are the observations with the 5 lowest and the 5 highest values in the data. That's good information to know. Here's another question. Look at the list of highest values. How many individuals in the data have a salary over $40,000? Only one individual in record 17, or what we call observation 17 in SAS, has a salary over $40,000. Now that you've seen different types of HTML and text reports, let's look at some charts. Here's a 3-dimensional bar chart. In this frequency report, job title appears on one axis and gender on the other axis, with frequency count as the height of the bars. Notice that when the mouse hovers over one of those bars, the values for the bar appear. This feature is especially useful if one of the bars is somewhat hidden in the background. Finally, we have a 3-dimensional pie chart showing the total salary by job title for warehouse assistants. We've exploded the slice for Warehouse Assistant 2 to highlight it. Try one last question. Which job title accounts for more than half the total salaries for warehouse assistants? The sum of salaries for the Warehouse Assistant 1 job title is $262,615, more than half the total. That's all of sample reports for now. You've seen list reports, frequency reports, statistical reports, and charts.
Now that you know some general capabilities of SAS, let's see your choices for running SAS. You can run SAS in interactive mode, in batch mode, or in non-interactive mode. Let's look at each mode. In interactive mode, you enter and submit SAS code that runs immediately. This is the mode you'll learn to use in this course. You can use the SAS windowing environment as your interface in interactive mode. In the SAS windowing environment, SAS displays the results as soon as your program runs. You can then check the SAS log, modify and resubmit your code, and view SAS help and documentation. Interactive mode is useful for writing, testing, editing, and debugging your SAS code. In interactive mode, you can use all the features of the SAS interface to work with your SAS files. Although SAS Enterprise Guide is a separate application, it is similar to interactive mode because programs run as soon as you submit them to SAS, and the results are returned to SAS Enterprise Guide. In this demonstration, we'll run SAS in interactive mode using the SAS windowing environment. If you are using SAS Enterprise Guide to take this course, you can skip this demonstration.
You can start SAS in several ways, but here we'll double-click the desktop icon to start SAS in interactive mode on Windows. The examples in this course show SAS in the Windows operating environment. At the end of this demonstration, you'll have an opportunity to see SAS in Unix or ZOS. When SAS opens, we see the interactive windowing environment. This is the interface we'll use throughout this course. Notice the Results and Explorer windows on the left and the Log and Editor windows on the right. The Output window is also open, but it's behind the Log and Editor windows. Generally, in this interface, you write SAS programs to perform programming tasks. Many SAS programmers prefer the SAS windowing environment because of its power and flexibility. This interface provides tools for programming, including windows for entering and editing code, checking the log, viewing and managing output, viewing and managing SAS files, and debugging programs. Each time you start SAS, you see some messages in the log window, including copyright notes and the version of SAS. One important piece of information is the site number. If you contact SAS technical support by telephone or website for assistance, SAS requests this site number. Remember to make a note of that number once you start SAS. Here's a question. What is the site number in the log window shown here? The site number is 784-716-2208. Remember, throughout this course, you can click the Unix or ZOS button for more information. For example, to see SAS in Unix or ZOS, click a button below.
Now, let's explore running SAS in batch mode. To run SAS programs in batch mode, you create a file that contains SAS code plus any necessary operating system control statements. Then, you submit the file to your operating environment. This example shows a batch file in the ZOS operating environment. Here, the operating system control statements are in Job Control Language, or JCL. When you submit a batch job, SAS runs the program in the background by submitting it to the operating environment for batch execution. This means that your program runs when the computer has resources available, but not necessarily when you submit the code. Batch mode is most common in mainframe operating environments, such as ZOS. You generally use batch mode for controlling computing resources, or if you want to use your terminal for other work while your program processes. You can also use batch mode to schedule programs to execute at a certain time on a certain day. You won't learn how to submit a program in batch mode in this course. For more information on batch mode, see SAS help and documentation. In non-interactive mode, you store SAS programming statements in a file. When you issue a SAS command referencing the file, SAS opens, executes the code immediately, and stores any log messages and output in files. Then, SAS closes. The form of the SAS command varies depending on your operating environment. Also, the command for invoking SAS at your site might be different from the default shown here. If you're interested in using non-interactive mode, ask your SAS administrator for the command. You won't learn how to submit a program in non-interactive mode in this course. For more information, see SAS help and documentation. Now, check your knowledge of SAS processing modes. Now, try starting a SAS session in Interact. Now that you know a little about SAS software, let's take a look at the overall programming process in SAS. The first step in the programming process is to define the business need. You do this by communicating with the business team or by reviewing a written specification. After you define the business need, you write a SAS program based on the desired output, the necessary input, and the required processing. After you finish coding, you run the program and review your results, which can be reports or notes and messages from SAS regarding your code. As you review the results, you might find inaccuracies or errors, in which case you might need to debug or modify the program. Depending on your results, you might need to repeat some of the steps, as the diagram shows.
Let's see the SAS programming process in action. You'll learn how to perform each step in the next lesson. In this demonstration, just get a sense of the overall process.
This demonstration is specific to the SAS windowing environment, so if you're using SAS Enterprise Guide to take this course, you can skip this demonstration.
We've opened SAS and are now in the SAS windowing environment. Let's assume that we've defined our business need and planned our SAS program. First, we enter the program in the editor. For convenience, here we'll paste in the program instead of typing. The program creates a SAS dataset and produces 2 reports. Don't worry about details here. You'll learn more about SAS datasets and reports later. Next, we run the program. The last report appears immediately, and we review it. We can navigate to our first report and see it too. Part of our program created a SAS dataset. Here's a question. What could we do to verify that the dataset was created successfully? One thing we could do is check the SAS log. It's always important to check the log anyway. Interesting, the program did run, but the log shows that a keyword was misspelled. We'll return to the editor and correct the misspelling. To be on the safe side, we'll resubmit the program and check the log again. Here's another question. What else could we do to verify that the dataset was created successfully? We could also view the data to make sure it looks correct. The dataset looks fine, so we'll save the program. This program was easy to debug and modify, so we repeated the programming process only once.
In the previous demonstration, you saw how to work with the SAS program in the steps of the programming process. Now, let's investigate the main components of SAS programs. Generally speaking, a SAS program is one or more steps that you submit to SAS for processing. For example, here's the SAS program we ran earlier. It contains a sequence of steps, each of which performs a specific task. Let's examine these steps more closely. Only 2 kinds of steps make up SAS programs: data steps and proc steps. A SAS program can contain a data step, or a proc step, or any combination of data steps and proc steps. The number and kind of steps depend on what tasks you need to perform. A data step typically takes data, processes it, and creates a SAS dataset, which is data in a form that SAS understands. So one of the primary purposes of a data step is to create a SAS data set. In addition, a data step can create new variables that were not in your data. In SAS terminology, variables are the columns in your data. For example, suppose your raw data file contained the fields cost price per unit and quantity sold. In a data step, you could multiply these to create a new variable called total retail price. A proc step, proc is short for procedure, typically processes a SAS dataset. Various proc steps generate reports and graphs, manage data, and sort data. So, for example, you could use a data step to get your data into the form of a SAS dataset, then use a proc step to process the data in the SAS dataset and create a report. Remember, though, that this is just one possible combination of steps in a SAS program. Your SAS programs might perform other tasks. Here's a question. How many steps are in this program? The program contains 3 steps, 1 data step and 2 proc steps. The data step creates a temporary SAS dataset named work.newSalesEmps by reading 4 fields from a raw data file. The name of the raw data file is specific to a given operating environment. The proc print step creates a list report of the work.newSalesEmps dataset. The proc mean step creates a summary report of work.newSalesEmps with statistics for the variable salary for each value of job title. In addition to data and proc steps, this SAS program also contains global statements. These statements can lie outside data and proc steps, and they can affect more than one step. For example, the first title statement specifies a title that appears on both reports. The second title statement turns off all titles for all subsequent output. You'll learn several global statements in this course. Now answer a few questions about SAS programs. Try one last question about SAS programs. Here's what you learned in this lesson. Now, test your understanding by taking the lesson quiz. Here's what you learned in this lesson. In previous lessons, you learned about SAS capabilities and the overall programming process. You learn to open a SAS program, navigate the SAS windowing environment, submit the program, and view your output. You also learned about SAS libraries and how to get assistance by using SAS help and documentation. In this lesson, you learn about SAS code itself. First, you learn about the structure of SAS programs. Then, as you work with SAS programs, you'll add descriptive comments and diagnose and correct syntax problems. Finally, you'll save the program for future use.